Good afternoon, everyone. Thanks for joining us for our webinar, How Property Managers Can Reduce Energy Costs and Look Great to Building Owners. My name is Sandy Wiechmann, and I'm on the sales team here at Onset. Before I turn the presentation over to our presenter today, Brendan Milstein, I'd like to give you a brief introduction. First, a brief overview of Onset. For those who don't know us, we're synonymous with the industry-leading HOBO data loggers. We've been designing data logging solutions since 1981 right here in Massachusetts on beautiful Cape Cod. Our logging solutions are used all over the world for monitoring building performance, environmental changes, and water quality. We engineer and assemble all of the products we sell and have a global network of dealers to service our customers around the world. I welcome you to take a spin on our website at onsetcomp.com. The webinar will last approximately 1 hour, 45 minutes for the presentation and 15 minutes for your questions. Should you have questions, please type them into the questions field on your go-to control panel. If we don't get to everyone in the allotted time, we'll follow up with you after the presentation. We are recording the webinar today, and you will receive a follow-up email within a few days to link to the recording so that you can review it at your own convenience. Brendan Milstein is the founder and CEO of Carbon Lighthouse, an energy firm that makes it profitable for commercial and industrial buildings to eliminate their carbon footprint. Carbon Lighthouse collects and analyzes 1,000 times more data per site than normally observed, which results in energy savings delivered at half the cost of market. Carbon Lighthouse has completed over 90 projects in California and Oregon, and clients include Tishman Speyer, the San Francisco Ballet, Squaw Ski Valley Resort, City of Benicia, City of San Carlos, and other commercial and industrial buildings. The average savings that Carbon Lighthouse delivers is about $3.86 per square foot. Brendan obtained an MBA from the Graduate School of Business and an MS in Renewable Energy Engineering from Stanford University, and he holds a BA in Physics from Harvard. Welcome, Brendan.
Hi, thank you so much for the intro, and it's a pleasure to be here. It looks like there's a couple hundred people online and a fairly good mix of property managers and engineering firms, and also corporate real estate execs. So there's sort of a broad audience, and I'm going to do my best to speak as helpfully as I can to everyone. If you have questions, please feel free to type them in. I'll skim the question list at the end of every slide and answer things accordingly. This is an outline of what we're going to talk about today. So we're going to discuss net operating income. So this is really targeted towards property managers and what makes property managers shine. We'll talk about energy in the context of lease structures a bit. Then we'll get into how energy use is actually reduced, some common myths, and a case study. We'll talk about demonstrating it to ownership, which can either be, if you're an engineering firm, this can be your clients. If you're in corporate real estate, this can be your own company. If it's property management, it can be a separate owning company. We'll talk about some of the most common opportunities that data loggers help us uncover, and we'll have a quick little conclusion. So to put things in context here, I think the first large issue is that property management is really, really hard. So this is a highly competitive field. Buildings tend to flip fairly quickly, and whenever a building flips, it's very common for the new ownership to put things back out to bid again. So basically, a property manager may not be with a single building for more than just a few years, which doesn't give them a lot of time to fix any issues or really demonstrate huge value to owners if they're only with an owner for a year or two. There's a lot of different property management companies, and owners tend to focus on buying and selling, not actually managing the buildings, and we'll talk about that a little bit more in another couple slides. So there is one very powerful friend for property managers, however, and that is the net operating income. So net operating income, this is, I'm sorry if we're doing a bit of review for people here, but we'll move fairly quickly through this. Net operating income is all of the money a building takes in, so all of the rent and any other fees the building is able to charge tenants, and then you just subtract off all of the costs the building needs to pay for. And depending on lease structure, these costs can be very, very different. So that's what net operating income is. We'll see in a moment how it's so leveraged, and the other benefit of net operating income is actually property management can, in fact, influence parts of the net operating income very heavily, and specifically on the energy front, which is kind of the whole point of this presentation. Okay, no questions, so we'll keep moving. Context. So BOMA is the Building Owners and Managers Association. They do surveys annually and release the data. So basically we know managing a building is on the order of $8 a square foot. Now this obviously varies highly if you're running an industrial cold storage facility versus a typical office building versus a school. But these are the averages. And you can see that utilities, namely energy, so electricity, steam, natural gas, fuel oil, if that's what you heat with, represent the single largest component of this, which is good news because that's actually one of the largest things you can modify. Unfortunately, this is not very high compared to rent. So this number, we're based in San Francisco, so $30 a square foot here would actually be relatively inexpensive rent. The range for San Francisco is $30 to $60 a square foot. I have former experience in New York where rent could have been anywhere from $20 a square foot to $150 a square foot, depending on where you were in the facility. So you can see this compared to all the other costs down on the bottom, and it really just dwarfs them. So this is why property managers and many other people who manage or own buildings actually don't care so much about utilities or any of the other individual costs and focus so much on rent. But let's talk about how net operating income is highly leveraged and why utilities actually can still be important and worthwhile to look at. So the first thing is 30 cents a square foot is pretty reasonable savings for what you can get from a really good energy efficiency project. But rather than think about it just as 30 cents, this could actually be worth well more than $1 million. So how? So the value of a building is simply defined as its net operating income divided by its cap rate. The cap rate we'll sort of skip over because there's tons and tons of research into how cap rates are actually established. But basically think of cap rate as a market number, and typical cap rates are between, say, a 4 cap and a 7 cap. And those are actually percentages. So a 5 cap refers to 5%. And so what you end up doing is you look at your net operating income and you divide it by a percentage. So any increase in net operating income becomes highly leveraged for actual value. Hang on, I see a comment that my voice is gone, which would not be good. Can one of the organizers let me know that I can still sound okay? It's back. All right, lovely, thanks. Okay, so basically if we're able to get 30 cents of increase in net operating income in a 200,000 square foot building that has a 5 cap, that's actually worth $1.2 million when the building then gets sold. So that's no longer a small number. That's actually probably worth an hour-long meeting or hour-long webinar to figure out how this can happen. So you can look at this in another way if my slides are advancing, which they're not. Still not encouraging. Okay. There we go. That got it. Sorry about that. Okay, so this is sort of the same thing spelled out. And again, 30 cents a square foot, you can actually probably apply something like this. It depends on the building. Sometimes it's as low as 10 cents, sometimes it's as high as 50. But you can really apply this to your entire portfolio, which is kind of a nice thing about energy efficiency. It's replicable everywhere. So let's talk about the difference between energy savings and net operating income. And again, we'll move through this fairly quickly. I recognize a lot of people here are seasoned property managers, so I apologize for the review, but I'd like to get everyone on the same page before moving on. So energy and lease structures. So there's really this tug of war between where the energy savings go, between the owner and the tenants in the building. And this isn't super safe for work, so we'll move on quickly. But basically, depending on the lease structure and the very fine details of the lease structure, the most exciting part of any building, the energy savings can accrue basically anywhere. So let's look at a few of these. We're going to do this pictorially. So on the left-hand side, I've got Ray Charles here. He's going to own our building. And on the right-hand side, I have some model with pixelated glasses I found on Google in 10 seconds. She's going to represent the tenants. So there's a lot of different lease structures. For the purposes of this webinar, we'll call a full-service gross any lease in which tenants only pay rent. So there's no CAMs, there's no repair and maintenance, it's just rent, and the building owner pays for absolutely every expense. In that case, any efficiency project delivers savings directly to the owner, which is great. But that's usually not what happens. Normally, you have some sort of modified gross. Modified gross leases can come in many, many, many types of forms. So some of them have base years, some of them have common area and maintenance charges, or CAMs. Some of them have repair and maintenance, some of them have a clause for capital expense recovery. So these are all ways for the building owner to say, okay, tenants, you owe me rent, but you also need to pay for some of the ongoing maintenance of the building. And this differs basically with every lease. Often within a single building, there can be many different types of these leases that are negotiated. So that means they can change from tenant to tenant, from year to year, from building to building. And they're never really standard. And based on the details, some money from efficiency can go either to the owner or the tenant or both. And then the last is the triple net lease, and this is where the tenant pays for absolutely everything, and actually according to generally accepted accounting practices or GAAP, the tenant actually owns the building if the triple net lease is longer than a certain duration of time. Okay, so all of these different people can get the money. You'll note this is a presentation about how property managers can reduce energy use and gain recognition, and yet in none of these cases is there actually a property manager listed as getting direct savings. So that's kind of a huge hurdle we as an energy industry need to overcome, and this is a little bit about how to do that. I have some questions here on the right, so I'm going to skim through them real quick. Yep. Okay, and it looks like we'll get to those later. Okay, so back to figuring out how to advance the slides. Exciting. Success. All right, so reducing energy use, some common myths, which we need to overcome if we're going to get property managers to actually get excited about reducing energy use. So because they're not getting a direct cut of savings, usually, and there are some exceptions here. So CB Richard Ellis, for example, Jones Lang LaSalle, these are really huge companies, and they do occasionally go to the CFO of some of their larger tenants, like Bank of America, for example, and say, hey, we can reduce all this energy use, we want a small cut of it. But except in that case, property managers aren't getting a direct cut of the savings, and if that's the case, that means energy efficiency projects need to be really fast and really easy. And the other thing is they need to make property managers look awesome. And what I mean by this is not just vanity. If a property manager has a million issues going on in a building that they need to solve, like pipes breaking, toilets breaking, painting needs to be redone, the lobby is getting redone, there's a lot of problems. And the property manager is expected to solve those problems. And so doing an energy project is kind of above and beyond their normal purview of just making the building run and making the building run well. So if property managers are going to go above and beyond to actually do energy reducing projects, I believe they deserve recognition for it. And so I think that's a key part of any energy project, is making sure the people who go out of their way to do it gain the recognition they deserve. Also, again, because there's no direct financial incentive for property managers who are really pitching these projects to owners and getting them done, it needs to be fast and easy. So myth number one we're going to dispel. Energy retrofits, these don't actually require any owner capital. So we've done, in the past 2 years, a little more than 90 buildings. We've identified and delivered millions of dollars in utility savings. The most expensive piece of capital equipment we've ever asked a client to install is a variable frequency drive. So except for VFDs, all of our costs have been passed through to tenants as either common area maintenance or repair and maintenance. One critical thing about this isn't passing the buck. in leases where there are CAMs and there are R&M, it is the tenants that are usually getting the energy savings. So being able to align costs with the people who are actually receiving the benefit is an important part of this. So there's no owner capital needed for a good efficiency project. So certainly sometimes you'll need to replace a boiler or a chiller when it's at the end of its useful life. But for the most part, you can deliver excellent energy savings in a building without major capital and without any capital from the owner, which is good if the owner is not going to get the utility benefits. So the next thing that's good to know about energy saving projects is they can actually be totally implemented in less than 3 months. So the type of project we're talking about here is not a boiler or chiller retrofit. These are controls-based, data-based projects. And so they're able to deliver the same level of savings as a major capital project, but they don't require capital and they don't require a lot of time. And we'll get into the details of how we're actually doing that in a little bit. So the next lovely thing about efficiency projects is they can in fact be measured and verified and proven to directly increase the net operating income. And so that's a really key thing I think solar has done a really great job with that energy efficiency hasn't to date. And so solar, you install a bunch of solar panels and you meter them and you can just see the electricity they produce. With efficiency, it's much harder, but it's still completely doable. But to do it, you need a ton of data. And if you don't have this data and you can't prove the savings, there's really no value to the property manager. Because now the property manager has just spent a ton of time doing a project and they can't demonstrate any value to the building owner, to their tenants, to their clients. So if someone's going to spend time doing something, you need to be able to prove for them that it actually did something. And then the next thing is if you can't prove this, you run the risk of savings actually not materializing. And unfortunately, not all energy efficiency projects are created equal. There's a big difference between a product and a project, and efficiency is a project. And if you don't verify things, you can actually have not real savings. And if the savings aren't real, that's really a negative value to everybody. So the property manager has spent time doing something that didn't deliver savings. Tenants have spent money paying for something that didn't deliver savings. So getting data to really demonstrate these savings is really, really crucial, both on the positive side of being able to gain recognition for what you have in fact accomplished, and on avoiding the negative side of spending capital in a non-beneficial way. So great. On to the actual case study and how it is you can deliver savings in a building. So the case study we're going to talk about today is the flood building. So this is in San Francisco. It was built in 1904, so it's actually one of the only 2 structures in San Francisco that survived both the 1906 and 89 earthquakes. So that's pretty encouraging about the original design build. It has major retail on the first floor, so it's actually the flagship stores for Gap and Anthropologie. And it has offices on the 2nd through 12th floor, and it's actually more than 350 different offices in there. The other thing that's exciting to notice about this is before we started work here, it had more than a 90 on the Energy Star score. So that means this building was already more efficient than 90% of similar peer buildings in the country. So that should be a good indication to everyone here that even if buildings are already efficient, there's still plenty of room left for improvement. So how the building actually heats and cools, it has a cooling tower for water source heat pumps in retail. There's no cooling in all the offices. There is steam heat in all the offices, and it had already done a lighting retrofit. So if it's already so efficient, what is the point of looking at this thing? Well, we found $1.2 million in savings, and there was no owner capital expenses, which is good because all of those savings are in fact going to Gap and Anthropologie and the other tenants in the building. So the value of data, we don't need to guess at what energy savings are from things. We can actually figure that out ahead of time. And while best practices typically would recommend installing variable frequency drives on your cooling tower fans, in this particular building, that was going to cost somewhere between $30,000 and $40,000, depending on the bids we got and which firm we ended up using. But it was only going to save $1,100 a year. So this is a great use of calculating savings ahead of time and why you should really study things before you do them. And I'll get into some of the methods we do for that as well in another couple slides. So cooling tower VFDs, definitely not a good idea here. What about LED lights? Well, it turns out there were a couple places those were very worth it. So replacing MR16s and PARs, so these are kind of the can lights. So these are small lights. These aren't the big, horrible fluorescent lights you see on the roof of, imagine your elementary school when you were a kid. LEDs still aren't good enough to replace those yet cost effectively, but for smaller lights, they actually worked pretty well. They had a pretty good payback based on energy savings alone, and that's ignoring maintenance. So a lot of these things went in fixtures that required a scissors lift to change. So you're able to actually reduce maintenance time there since these things last way longer than incandescents. And, of course, they qualify for rebates, and everyone loves free money. So what about high bay lights? There's also a loading dock at the building, and this has it's called a metal halide light. If you're non-technical, this basically means a really, really bright light. And you can choose to replace it with LEDs, or you can choose to replace it with CFLs. In very high settings, you can also replace it with a number of other fluorescent options. In this case, the ceiling's fairly low in the loading dock. And what we found here is basically the CFL replacements and the LED replacements used about the same wattage. But the LEDs cost more than 3 times as much as the CFLs. So I would say at this point, and given the rebate structures in San Francisco and California, for high bays it was still much better to go with compact fluorescent lights instead of LEDs. So again, using data loggers to log operating hours and calculate actual savings ahead of time avoided a lot of wasted capital. So that's good. But the lighting projects are small. The real savings here, oh, I'm sorry, I have a question. Maybe I can answer this. Okay, so the question is, what is the life cycle of LED versus CFL? This is a really great question. So LEDs do definitely last longer than CFLs. So you need to look at the maintenance savings of having LEDs need to be replaced less often. In this case, the operating hours in the building are relatively low. So both bulbs, both LEDs and CFLs, were going to last, more than 5 years or 7 years. So the additional maintenance savings from LEDs weren't worth it. But if you do have lights that are in very difficult places to reach, that run 8,760 hours of the year, then it can make a lot of sense to spend the additional capital up front to get LEDs as opposed to using CFLs. And so as long as we're on a webinar hosted by Onset, I will say the key thing to do here is actually log the lighting hours and know what you're getting. So it's very different if your lights run 1,000 hours a year versus 8,000 hours a year. And with data loggers, you can figure that out. Cool. Okay, so much, much larger savings. The savings we tend to find in buildings are much more based around optimizations. And so there's optimizations that can be done in fans versus pumps and compressors and continuously optimized. So I've just said optimization a whole lot. What do I actually mean by that? Let's take a very specific system. So in the flood building, there's cooling towers and there's water source heat pumps. And if you use the fans more at the cooling towers, you give colder water to the water source heat pumps. And that means you have a fan penalty, but the actual water source heat pumps themselves are more efficient. And using data loggers to measure power and current and water temperature and fan cycle rate and a whole bunch of other things, you can actually figure out exactly where the optimal point is. And you can actually, that optimal point will change based on outside air temperatures and conditions inside the building. And you can measure all of those things and be continuously adjusting the temperature of the water, which in turn, adjusts the amount the pumps are working and adjusts the amount the compressors are working and adjusts the amount the fans are working. Aha! So we did this, and you can see one of our engineers, Matt, he's using an ultrasonic flow meter to measure the flow of the actual fluid in the pipes. And what we ended up doing here was adding a new brain for the BMS and adding a whole bunch of sensors so we could actually measure all of the points that impact compressor use and fan use and pump use. And so what we ended up doing was customizing an algorithm specifically for the flood building to continuously measure these points and adjust the operations of the building accordingly. So this is pretty cool because this is stuff you couldn't do, even in the late 80s. So technology has really progressed, and the result of this is that we were able to deliver $1.2 million in lifetime energy savings for the tenants, which is great because this is usually where projects go to die in commercial real estate, which is the tenants get all of the savings, but the owners have to pay the cost. And in this case, and there's a number of other firms that do this, which I'll talk about towards the end, but in this case, the tenants were getting all of the savings, and the owner did not need to put up any capital. Because, whoa, that looks not so good on my screen here. Okay, it looks better for the audience. No, it looks bad. We'll move on. Anyways, we were able to do the project in about 2 weeks. Tenants or occupants in the building never even knew it was going on. So that's really good news. If you're doing projects that are impacting occupants, you're not going to have very happy property managers or tenants or owners. So the fact that we could do all of the programming for the building management system off of site and simply upload it and do a very fast changeover made sure that there was no disturbance to occupants. And so again, you don't need major capital equipment and you don't need major construction to yield really great energy savings. All you need are very, very intelligent and data-driven algorithms to better control existing equipment. And then the other thing that this happened with, that this gave, which was a complete non-energy benefit, is now there was a fancy web-enabled building management system, so property managers and engineers can log into the building from off of site and make adjustments and have insight into the way the building's running. So that's all great, but again, it doesn't do anything for the property manager if there's not a way for them to gain recognition for all the time and energy they spent putting into working on the project. So thankfully, though, we were able to get some of our clients on Bloomberg television for the flood building in particular. Other of our clients have been on CNBC. And this is actually really important. If you're doing an environmental project, and any energy project that's reducing energy use is an environmental project, the marketing benefits can often outweigh the actual energy savings. And so actually promoting that and helping your clients with marketing and helping clients gain recognition for their environmental benefits that are also profitable for tenants and owners is very important. And thankfully the media is relatively receptive to that, so that can be pushed a little bit. I see I have a question here, so let me see if I can answer it. Oh, I have a lot of questions here. Okay, we may need to skip these until the end. Forgive me. Yep, okay. There's one question here that I will answer quickly, which is, what do you mean by a customized algorithm? So I apologize if I did not explain that clearly enough the first time. Every building is different. So basically, how efficient a cooling tower is depends on a whole lot of factors, more than just the manufacturer of the cooling tower. And likewise, how efficient a cooling system is depends on a whole lot of factors other than just the manufacturer of the cooling system. So in each building, it's a slightly different ideal water temperature, ideal water flow rate, ideal fan cycle rate type of thing that leads to the most optimal whole system. And so when I say customized algorithm, what I really mean is that the system, the entire system in that particular building has been optimized as opposed to something generic. So something generic might be 75-degree water is the most efficient water for a cooling tower to create, whereas something building specific might be, in this building during these circumstances 74-degree water is better, but under these other circumstances 76-degree water is better. Sorry if that was technical, but hopefully that helped. Cool. Okay, so moving on, environmental impacts of the project. I am an environmentalist at heart, so I do actually care about these quite a bit, although I will say Carbon Lighthouse's mission is to make sure that any environmental impact we do is also profitable for our clients and tenants and building owners and occupants. But we did get 870 tons of CO2 per year in the building. To put that in context, 1 pound of CO2 is about 3 big black garbage bags worth of air. So if you want to multiply that by whatever 870 times 2,000 is, it's an awful lot of garbage bags we're taking out of the atmosphere. So that's exciting, and then you can have a very pretty picture of a stream in fall to demonstrate it. Cool. And now I need to figure out how to progress the slides again. Okay, so demonstrating it to ownership. It's one thing to talk about all these great things that you've done in a building. It's another thing to actually be able to show it in a way that is convincing. So how do we do it? Well, again, data is your best friend here. And in this case, we're showing just a very simple onset data logger. There's a lot of other tools we have to measure data. Some of these are also made by Onset. Others are made by other companies. I do love Onset, though. But basically, you can't just talk, or at least I prefer not to. I prefer to actually measure things and then show people pretty graphs. And these are the tools we use to do that. So again, to recap, if property managers aren't getting direct money, things need to be easy, and they need to be proved to the owner to have any value to the property manager. So what do I mean by being proved to an owner? So these are predictions Carbon Lighthouse made a year before then measuring what an air handler was actually doing. So you'll note the percent air here is absolutely tiny. It's 1/4%. So in other words, if we predicted $100 worth of savings, we were likely to be incorrect by 5 nickels. So not too shabby. And this is entirely enabled by getting data. So to make these predictions, we measure temperatures in return air, in outside air, in mixed air. We measure electrical current and voltage and power factor going through compressors and fans. We measure all sorts of things, and we do an awful lot of regressions, basically to figure out how all of these factors play together so that we can make predictions. And when we make predictions, we make them by the hour. So rather than just looking at 1 month of utility bill, we can predict the energy use of any individual circuit by the hour a full year ahead of time. And so then to actually measure and verify a project later, all we do is go back to site and measure the outside air temperature and measure the power going through an individual air handler or circuit we predicted. And then we can say, look, it matched the predictions, or it didn't. Now, there's obviously a split incentive here. If Carbon Lighthouse is the one implementing an energy project, you might want to have a third party verify savings. And that's fine. There's lots of third parties that verify savings. So this is a slide basically taken from a measurement and verification report made by Gridium, which does a lot of statistical wonders with interval meter data, which is 15-minute utility data. And you can see here that they've shown the difference in energy use before and after the project. So basically the highlighted green area is all of the energy savings from the project they were verifying. If you want to go cheap, you don't need to use third party. You can just look at your own utility use and draw a line before and after the project, and you can see that energy savings should go down. If you're doing a gas-only project, there's other ways to verify it. You only have monthly data, so you can't be quite as precise with things. But basically the blue line is the energy use corrected for temperature before the project was done. You can see the red line is the energy use corrected for temperature after the project was done. HDD is a heating degree day, by the way. It's a measure of temperature. But basically the important thing is that when you compare utility use ahead of time and after, it should be actually lower. And it should match, that difference should match predictions. And you should be able to see this on a bill. We don't disclose client bills, so I found one on online from Hawaii. And you can see here that basically the kilowatt hours per day was about 12% lower than the same meter read a year before. So ultimately, before a project and after a project, this should show up on the bill somehow. And I think it's in the energy service provider's court to really demonstrate that. And there's a lot of different ways to demonstrate that. So what does this actually look like in a building? If I could advance the slides, I can answer. Okay, so here is a very small rooftop unit, or RTU. So this is basically an air handler. It takes air from inside the building and from outside. It mixes them together. It conditions the air to the proper temperature and humidity, and then it puts it back inside the building. And there's an arrow pointing to the panel we will be looking inside. So a really, really bad energy efficiency project looks something like this. So there's a bunch of control wires that are dangling, not connected to anything. Let me see if I can figure out how to use the highlighter here. If we look here, yeah, that may or may not be working. This is just a hole. There should, in fact, be a damper there, not just a hole. And that damper actually turns out to be lying on the ground here, preventing any return air from coming into the building. So at least in this case, this economizer, that's what this guy is called, is failed in a way that's not dangerous to occupants, namely there is still fresh air coming into the building. Let me see if I can now advance the slides again. Cool, that looks like it maybe worked, maybe not. Yeah, there it goes. Okay, so there's a bunch of arrows here that show the way this is supposed to work. So we just walked through this, but basically where that giant hole is where outdoor air comes in, and where the return air should come in is completely blocked by a damper. What this looks like when it's working should be something like this. So now there's controls, there's dampers that are being lowered and raised, and this is what it should look like when you open up the machine. The problem is, even when it looks like this, you're not necessarily sure that it's working. So just because the dampers are in place doesn't mean they're moving at all, or when they should ideally. So how do you figure this out? Well, you use data loggers. So the blue arrow there is pointing to one of these little data loggers. This is just before the supply fan, so what we're measuring here is the mixed air temperature. So this is the temperature of the air basically before the air is conditioned, but after return air and outside air have been mixed. And if you look at the mixed air temperature, okay, good, the slide's advanced. If you look at the mixed air temperature and compare it to outside air temperature, what you should see is not this. This indicates that your economizer is letting in about 95% outside air all the time. In other words, it's not recycling air from inside the building. So if it's a pleasant 60 degrees outside, that's wonderful, but if it's 100 degrees or 20 degrees, you're spending an awful lot of time and energy conditioning air. Now, what your mixed air temperature should show you is this. Let's go back one. Is this. You should see a big kink. So you can see on the blue side of the graph, you're getting a lot more outside air, and on the orange side of the graph, you're going down to minimum position, which in this case is about 30% outside air, which in fact is a little bit high. You should be closer to usually 20% or 15% is common. So either this particular air handler needed to provide more fresh air than normal to the building occupants, or there's some leaking dampers, which is pretty common. In San Francisco, it's not really worth the extra $1,000 to fix dampers to go from 30% to 20%. I apologize for the sirens in the background, if you can hear them. Anyways, the whole point of data is you should be able to predict energy savings ahead of time, and then you should be able to measure them and actually show what happened with real energy savings on the bill. And so this is the results from one of our projects. You can see towards the middle of the year, actual energy savings were a little higher than we predicted, which is great. But by the end of the year, they were just about even. In this case, you can't really tell on this graph, but they were about 6% higher than we predicted, which is great. All right, so let's keep on going here. Maybe I'll take a moment to answer questions. Okay. Question, how do you equate whole building energy use metering to sub-metered zones when different building zones may or may not be operated simultaneously? This is a really good and difficult question to answer. So there's a couple ways you can go about this. The first is you can get interval meter data from the building. So that requires you to be in a utility where interval meter data is in fact available. So if you can download 15-minute electric use from the utility, what you can end up doing is basically statistical regressions. So you can look at how the time of day impacts energy use, how the temperature impacts energy use. Ideally, you would get data on building occupancy, but you can work around it if you don't have it. Another good thing to put into your regression would be the difference in temperature from the building's balance point. So in other words, somewhere around 50 or 55 degrees, the building doesn't need to heat or cool. And you can look at a difference from what the temperature actually is to that balance point. So basically the difference between 75-degree outside air versus 55-degree base point. And you can basically add in all of these factors to predict energy use. And you should be able to predict the energy use of the whole building, even with differently submetered zones, if you're summing all the meters. You should be able to predict that more than 90% accurately ahead of time just through statistics. And once you have that established, then it's not so difficult to do the project and then see the difference between how the building's actually working and what your predictions said. If you can't do that because you don't have any one of those quite rigorous data streams that you need, you can measure individual systems you're changing. So we do this a lot, and particularly because building use changes, tenants and occupants can add data servers or remove them, so that obviously impacts the building use in a very large way. So we'll make predictions about individual circuits. So we'll predict what mixed air temperature should be, what flow rate and pipe should be, what fan speed should be, what kW use an individual circuit should be, all sorts of things like that. And we make those predictions by the hour, so after a month we have literally a few thousand different data points of predictions we've made to reality to compare. All right, and I have another question here. Do you find facility changes like fluctuating tenant occupancy to be a challenge in using the utility bills to show project savings in the commercial market? Yes, absolutely. So occupancy impacts utility use a little less than at least I would have expected when I was just getting into this, but adding a server rack makes a big difference. So that's why we end up making all these individual circuit level predictions. So that way if whole building use increases or decreases, we can go and measure those individual circuits that don't have the additional server rack on them. And that lets us see if we're making accurate predictions or not. All right, next question. When you are on a roof with multiple RTUs, how many do you monitor to put an energy project together? Okay, this is another really good and complicated question. It depends on the climate and the size of the building, the size of the RTUs, and their total number. So if you're in Minnesota, an individual 20-ton RTU may make a really good opportunity for a project, and measuring a lot of things about that RTU to see if it's scheduled, to see if the economizers are working, to see, depending on what's serving it, if it's optimized with the cooling tower, could be a fantastic project. If you're in the San Francisco Bay Area and you're looking at a building that has one chiller providing cooling to 3 different air handlers, that chiller might only run 200 hours a year. So even though it might be a big 500-ton chiller, it's still unlikely to give you a really good project. So I think it depends on a whole lot of factors, and you just need to get comfortable with them in your region and see, the results of doing projects and see what savings come from doing what. So high utility rates make projects easier. Inclement weather makes projects easier. Long operating hours make projects easier. Hopefully that was helpful. All right. So let's go on to some common opportunities. First things, this is not an exhaustive list by any number of measures. We're only going to talk about a few different things. We very frequently look at over 125 or so different energy efficiency measures that can be used in a building. And we do 47 or so different optimizations quite regularly. So this is just kind of top bullet list. Everyone talks about economizers. Let me rephrase. Every energy nerd talks about economizers. I need to cough. Excuse me a moment. All right, I'm back. Hope you didn't miss me too much. Okay, so energy nerds talk about economizers a lot. There's a lot of really good studies on this. Some are done by PECI, some are done by PG&E, others are done by independent contracting firms. But basically, they all come to about the same number, which is around 2/3 of economizers in the field are broken in one way or another. So this means either the dampers are rusted and can't move, or the linkages are broken, the actuators are broken, sensors aren't working, something's broken. So that makes economizers a really good place to look. Even in the Bay Area, where there's not that much heating or cooling costs, if you have more than a 10-ton unit, it can often be worth it to check out the economizer. VFDs, variable frequency drives, are the next great big thing that tons of energy nerds talk about. And I'm happy to say that, at least in California, most of the buildings we go into already have some of these installed. These are a great way to reduce energy use in pumping systems and in fan systems that have variable loads. So that's great. The one thing about VFDs, though, is that there's a lot more potential for getting savings out of them than just installing them and having them maintain a constant pressure. And so 2/3 of the savings from variable frequency drives will end up coming not just from installing them and having them continuously supply 1.5 inches of static or so, but once they're installed, you can then measure all these different points in the building, so damper positions, valve positions, whether zones are calling for heating or cooling or not, and you can actually really tune variable frequency drives to better provide savings and to adjust the set point they're trying to make based on building conditions and weather conditions. So if your building already has variable frequency drives, that's fantastic. It means you've already spent all the capital required, or at least the vast bulk of it, to get those in there, and you should really check them out to see if they can provide twice as much savings as they're already providing. Now the wonderful thing, and this gets into a question I've been asked here, which is, can you clarify where the money comes from to pay for your time if the owner's costs are zero? When you are better controlling existing equipment, so the variable frequency drive has already been installed, there's already some shell or a very old building management system, the costs for the project is really repair and maintenance of the existing system. So typically adding 20 sensors to a building management system, that's not a capital cost. Sensors are relatively cheap. And replacing the building control unit and installing better brains, all of this stuff can be passed through as repair and maintenance or common area maintenance charges. So this is really key because it's the tenants that are getting the benefit. So keeping your projects to non-capital projects, namely not installing a totally new air handler, but better controlling the existing air handler and optimizing the existing systems, lets you align the benefit, the costs with the benefit. So if tenants are paying for utility use, they're typically also paying for repair and maintenance. And making existing equipment operate better is definitely a repair or maintenance. In buildings where the tenant isn't paying the utility cost, I should clarify, in that case, all of these repair and maintenance charges to optimize the existing equipment do accrue to the owner. But in that case, all the savings accrue to the owner as well, so that's okay. So these projects, it's not pure retro commissioning. There are some hardware costs because you almost always need to add sensors, and you often need to replace the building control unit if there is an existing BMS. But it's still well below the capital threshold. I have another question here, so let me check it out. How do you get controls contractors to work well with O&M staff and engineering department? Oh God. So that's a great question. Engineering department, we've been fortunate with. I think there's really an awful lot of talented building engineers, particularly merchant marines. I can't speak highly enough. I'm always just blown away by those guys. Getting the O&M to play nicely with the controls contractors on the ground, that can be more difficult and require more work. I would say pleasant persistence is what Carbon Lighthouse has found to work well there. But project management, I think, should not be discounted. We do all of that stuff on behalf of our clients, but if you are in commercial real estate and are used to doing project management yourself, I would expect to spend a lot of time in that exact area. The other issue that's not mentioned in the question but I'll address is just because a controls contractor says something is installed and working doesn't mean it necessarily is. So we've had engineers go back to site and re-get data from data loggers 4 separate times on just a single economizer while all the kinks in the control system for that economizer were worked out. So these projects require a lot of finesse to make perfect, and they do have to be perfect because if that last step, namely sending the signal from the building management system to make a change, isn't completed 100%, the savings entirely evaporate. So that's a great question, and we spend a huge amount of time commissioning projects after they are, quote, fully implemented. So yeah, there's no magic bullet there. Yeah, sorry. All right, advancing the slides again. Okay, so there's another thing here to further develop the how can owners avoid capital costs if it's the tenants that are getting all the benefits. So Carbon Lighthouse lets owners or any client split up the payments rather than pay for everything at once. We're not the only firm that does this. Metris, Cedargate Capital, CalCef, there's actually like a dozen different firms that just provide payment structures for energy efficiency projects. So that's good news because it makes it much, much easier to move a project through repair and maintenance or CAMs if the monthly payment for that project is less than the energy savings. Again, I just want to reiterate that it's really a great thing owners are doing when they do this because typically what ends up happening is an energy project would have a 2-year payback, but all of the savings go to the tenant and all of the costs would go to the owner, so reasonably the owner doesn't do it. So when you have these financial structures and contract systems that really let the costs accrue to the person who's getting the benefit and let the benefit outweigh the cost every single month, you're able to get a lot more projects done. I have another question here. This is a longer question. I'm going to need to skip it for now. So anyways, Carbon Lighthouse so far has been able to make any project a client asks save more money than it costs in the very first year. So that's made budgeting and other contract issues much, much easier. All right, we need another slide. Okay, so optimizing controls. This is key, and what you want to measure and use data loggers to measure to do this is basically all the different current and power. And don't ignore power factor if you have large spinning machineries, so chillers or other large motors. Power factor can change a lot based on load, especially if you have a VFD installed as well. So measure actual power. And what you want to do is compare the power use to temperature of water or temperature of air, the flow of water or the flow of air, the outside air conditions. And what you want to build up is sort of an efficiency rate for the piece of equipment at every different type of experience it will have. So, you know, when it's cold outside, when it's warm outside, when it's cold outside but warm inside, or vice versa. And then what you want to do is look at the efficiency and overall energy use of all these different pieces of equipment and how they play together. And it takes a lot of data, which is why I like data loggers so much, to actually make these different efficiency curves based on load and conditions. But if you use data loggers well, you can develop all of this stuff. And this optimization between, you know, fans and pumps and compressors has really been letting us get 10 to 30% reductions in overall utility bills without major new equipment. So I can't stress that enough. All right. So, the other thing to point out is no matter how many people have gone through a building before, if you arm yourself with 1,000 times more data, which is what we typically do at Carbon Lighthouse, you're able to make better decisions and find opportunity that's been otherwise missed. So all of this optimization stuff, it can't be seen or known about without real data. And so not just utility bills. As awesome as interval meter data is, and as much as I love getting 15-minute utility usage, there's just no substitute for getting temperatures inside a building, for getting valve positions inside a building, and doing some serious regressions. So thankfully, that's exactly what data loggers let us do, except for the regressions. Those you have to do on your own. So we're almost to the point of getting to the conclusion, which is good. But one final word on data. Any good efficiency project should really involve data logging before and after the project. So any savings you predict, you should really be able to demonstrate those clearly afterwards. And savings should be known ahead of time, and they should be customized for your building or whatever your client is. So rather than saying, on average, variable frequency drives save 30%, which may be true, it really needs to apply to that particular building. So at the flooded building, for example, the VFD was not going to save 30%. It was going to save not remotely enough to justify its cost. So making sure your savings predictions are specific to your building is really, really key. And again, you should just measure it afterwards. So in conclusion, data loggers are great because you can find a ton of energy savings that don't require capital, and you can also use them to demonstrate those savings clearly to owners and tenants and yourself, which is good. Oh, another thing we didn't talk about, if you can demonstrate savings, utilities will usually chip in for a project. So that's always lovely. And then the other thing we did talk about briefly is commissioning is key, but again, that's just based on getting more data. So I've turned into kind of a data evangelist here. I should have warned you about that up front. And I would argue that data and actually commissioning and measuring things should be a requirement for any energy efficiency project. But the wonderful, wonderful thing is you can reduce energy use by 10 to 30% without new capital costs. And you can demonstrate this increase in net operating income and decrease in utility costs pretty easily with the data if you do good measurement and verification. And because you don't need major capital equipment, these projects can be easy and they can be fast. So we've got about 2 minutes for questions here, so I'll try and go through these. And I apologize, the questions window I have is very, very small. Maybe I can make it bigger. I cannot make it bigger. Ooh. All right, I can make it bigger. So yeah, please type in your questions, and I will attempt to answer them now. Okay, well, I have 2 minutes and like 80 questions here, so let's see. Give me 1 minute to skim through these. Okay, good. I actually have managed some of these. Okay, one question is for our custom algorithms in building automation systems. Do we design them in-house or do we outsource this to an optimization firm? We do all of that design and optimization work in-house. There's a number of firms that do this themselves and a number of firms that don't. And so either one is fine as long as they're willing to predict savings and then actually measure and verify them afterwards. Let me see if there's more questions that I can answer in the time we have. Do you weather adjust for your regression? Absolutely, and in a number of ways. So it's often not good enough just to do temperature. You often need a difference of the outside air temperature or, in some cases, wet bulb temperature to a balance point in the building. And sometimes the relationship is not linear. So sometimes the difference from 90 degrees to 55 degrees is much more important than 75 degrees to 55 degrees.
Brendan, I see a question here on does Onset have webinars for specific training on each type of data logger? And I would encourage you to go to our website, onsetcomp.com, and press under our learning tab, where you'll find a number of white papers, webinars, and myriad of different information on each specific logger and its use.
All right, great. Yeah, so that's very helpful. We've actually received, we have our engineers go to Onset and other training on tools as well, so I do definitely recommend training if some of this stuff is new to you. I see a comment on VFDs and the importance of grounding them. I agree with this very much. Grounded equipment is always good, and we actually always specify a bypass on our variable frequency drives as well, so make sure to look for that. Oh, here's a question about CO2 equivalence. So the question here is who gets the sort of legal right to the value of the CO2 benefits? The thinking, I think, behind this question is that there are markets both in the U.S. and the world where the environmental benefits can actually be sold. In the case of Carbon Lighthouse, we donate all of the CO2 benefits and other environmental rights that could be sold. We donate those to a not-for-profit, which then does not sell them. But that is up to the contract that ends up getting signed. So if you're a building owner and you want to make sure you retain those rights, you can just write that into the contract. Likewise, if you're a contractor and you're looking to monetize the environmental benefit, you can write that into the contract that you own them and then try and sell them on the third-party markets. For Carbon Lighthouse, we donate all of those to a not-for-profit to make sure we maintain our environmental mission. Okay, can you do stealth projects when it comes to acquiring interval electricity data? Doesn't that require you to temporarily turn off the breaker you will be monitoring? No, it does not, and you can absolutely do stealth projects with interval meter. So we're lucky in that we often get to work with Pacific Gas and Electric and other California and Oregon utilities where we get to just download the interval meter direct from the utility. You can also put metering equipment in panels while they're live, depending on the voltage and your state regulations. But obviously make sure you have a qualified professional doing that with proper safety equipment. I think we're out of time, so I apologize for not being able to answer all of the questions. Please feel free to email me directly. My email address should be on the screen, and I hope this was helpful. I'm not sure how to officially end the slideshow, so I'll leave that to Onset to do, but thank you everyone for your time.